So now we are going to solve one another example in order to find out derivative numerically for the unequal class interval. The data is a given for unequal class interval. So here, in order to save the time, already we write the problem. What is the problem? Problem is from the following data, find the value of f dash 6 and maximum value of fx if exists in this range. So if we closely observe the data, here the class interval is a 2. Here the class interval is a 2, here class interval is a 1, here class interval is a 1, here class interval is a 3, here 2, 3, 1, 1 and 2. This means the data is a given for unequal class interval. So we cannot use the forward interpolation formula, backward interpolation formula for the derivative, central interpolation formula for the derivative. So there is a need to either we use the Lagrange interpolation formula or we use the Newton divided difference interpolation formula. So here we are going to use the Newton divided difference formula. So as we know that, what is the Newton divided difference interpolation formula? Newton divided difference formula is a y equal fx equal what? Here f of x0 plus x minus x0, f of x0 x1, x1 plus x minus x0, x minus x1, f of x0, x1, x2, x2, and next term is x minus x0, x minus x1, x minus x2, f of x0, x1, x2, x3 and so on. Last term is x minus x0, x minus x1 up to x minus xn, f of x0, x1, x2 up to what? Xn, xn plus 1, xn plus 1, sorry, not xn plus 1, here xn minus 1 and here xn, because there is a n plus 1 data from x0 to xn. So this one is a formula for the Newton divided difference formula. This one is a Newton divided difference formula, just we write a Newton divided difference formula. So here what? This one is a what? This one is a first order divided difference. This one is a second order divided difference. This one is a third order divided difference. And this one is a nth order divided difference. So in order to find out first order, second order, third order, nth order divided difference, there is a need of a divided difference table. So in order to save the time, already we construct the divided difference table. So this one is a data is a given. This one is a x0, this one is a x0, x1, x2, x3, x4, x5, and this is the value of f of x0, f of x0, f of x1. You may also write this one is a y1. So f of x2, f of x3, f of x4, f of x5. As we know that, how we construct the divided difference table? This one equal to what? F of x1 minus f of x0 divided by what? Divided by x1 minus x0. So what is the value here? 26 minus 4, 26 minus 4 divided by what? 2 minus 0, 2, 22 by 2, this become 11. In a similar manner here, 58 minus 26 divided by 3 minus 2, then we are able to find out the 32, and 42 minus 58, 42 minus 58, 42, it's another 42, once we verify this one is a 42 or this 42, this one is another 42, 112, this one is a 112. So once we write here, this one is not 52. So this one is, I think, 112. This one is 112. I think this one is 112. This one is 112. 1, 1, 2, 1, 1, 2 divided by 4 minus 3. Then this one is a 54. Sorry. So again, if 466 minus 112 divided by what? Divided by 7 minus 4, then we get this data. And last one is a 922 minus what? 922 minus 466 divided by what? 9 minus 7. Then we get this result, these results. So how we find the second order? So in order to find out the second order, so this one is a 32 minus 11 divided by what? Divided by 3 minus 0. 3 minus 0. So this become what? 32 minus 11. This become 21. 21 divided by 3. This one is a 7. And this one give the 54 minus 32 divided by what? Divided by 4 minus 2. 4 minus 2, and this give the 118 minus 54 divided by what? Divided by 7 minus 3. 7 minus 3, and last one is a what? Last one is a 228 minus 118 divided by what? Divided by 9 minus 7, 9 minus 4. 9 minus 4, then we get this result, this result. In a similar manner, this one give the value for what? 11 minus 7 divided by what? Divided by 3 minus 0. 3 minus 0. Not a 3 minus 0, 4 minus 0. So 4 minus 0, so this become 1. In a similar manner, we calculate this one. 16 minus 11 divided by 7 minus 2. 7 minus 2, then we get the 1. And in a similar manner, this one is a 22 minus 16 divided by 9 minus 3. 9 minus 3, then we get this result. So, and this one become what? This one becomes 0 and 0. This one is a what? Divided difference table. So once we construct the divided difference table, then we know that this one is a value of f of x0, and this is the value for what? This is the value for f of x0, x1. And this is the value for what? This is the value for f of x0, x1, x2. And this is the value for f of x0, x1, x2, x3, and all other value with the 0. All other value with the 0 means we are going to use the formula up to a third order derivatives. Not a third order derivative, third order divided difference. So here already we write the formula. So here we put the values. So either we write once again a formula. So here we write the formula once again. So y equal what? Y equal f of x0. F of x0 plus x minus x0 f of x0 x1. F of x0 x1. F of x0 x1 plus here x minus x0 x minus x1 f of x0 x1 x2, and one another term because here third order divided difference, there is a need of a third order divided difference. So we write one another term x minus x0 x minus x1 x minus x2 f of x0 x1 x2 and x3. So we put these values here. So basically y equal what? F of x0 is a what? If we write f of x0 from here, the value of f of x0 is a what? F of x0 is a 4. 4, 11, 7, 1. 4 plus x minus, what is the x0? x0 is a 0, x minus 0, and f of x0, x1 is a what? 11. So, here we write a what? Here we write into 11 plus x minus 0, x minus x1, x1 is a 2, f of x0, x1, x2 is a 7 into 7 plus what? Again we write this term is a what? X minus 0, x minus 2 and x minus x2, x2 is a what? x2 is a 3, x minus 3 into what? Into f of x0, x1, x2, x3, f of x0, x1, x2, x3 with a what? 1. So, after simplification of this result, what we will get? Y equal 4 plus 11x plus what? This become x square minus 2x into 7 plus this become x cube minus 2x square minus 3x square plus 6x into 1. So, if we simplify this one, so y equal what? Y equal, there is a x to power 3 x, so 2x7 x square, so sorry this one is a plus 1 plus, so this one is a result, this one is a y. So, how we find the y dash? Obviously y equal, this one is a fx equal to this one. If we find the derivative become what? F dash x equal y dash equal 3x square plus 4x plus 3. So, this one is a what? This one is a f dash x. This one is a f dash x. So, in order to find out the value of a what? In order to find out the value at x equal what? Here there is a need to find out the value at x equal, derivative at x equal 6. So, here we put what? Here we put x equal to 6, x equal to 6, then we find f dash 6 equal what? 3 into 6 square means 36 plus 4 into 6 plus 3. So, this one big 3 6 is 18, 3 3 is 9, 9 plus 1 10 plus 24 plus 3. So, this become 5 4 3 7 8 15 2 3 135. So, what is the value of f dash 6? 135. Second part of this question is a what? Find the maxima value. Find the maxima value. So, how we find the maxima or minima? What is the necessary condition? First order derivative equal to 0. So, if we put first order derivative equal to 0 means a y dash equal to 0, then this means 3x square plus 4x plus 3 equal to 0. So, what are the values of x? X become what? Minus b minus 4 plus minus under root b square 16 minus 4 into 3 divided by what? 2a means a 6. So, x equal what? X equal here x equal minus 4 plus minus under root 16 minus 36 divided by 6. This means x be the imaginary value, imaginary root. So, what we conclude here? We conclude here what? We conclude here in this problem, the maxima doesn't lie between 0 to 9. The maxima doesn't lie between 0 to 9 because x is a what? X is a imaginary value. X is a imaginary value. So, here maxima value does not exist here 0 to 9. If we closely observe here, This one is a 1, 1, 2, basically 1, 1, 2. So, if we closely observe this one is a what? Increasing function. So, maxima does not lie in this class interval, means 0 to 9, the maxima does not exist. So, what is the summary of this lecture? How we solve any numerical problem? In order to find out the derivative, just we write a formula corresponding to the interpolation. Once we write a formula, then find the derivative of that formula. Once we find the derivative, then putting the values as per the need. What is the meaning of a need? If we try to find out the derivative near to the first value, then we use the forward, near to the last value, then we use the backward, near to the central value, then we use the central, and for the unequal class interval, we use the Lagrange interpolation formula or Newton divided difference interpolation formula. So, this one is a way to solve a numerical example. Directly we put the value of x, or we find the function which satisfies the given data, then we differentiate the function that we find with the help of a interpolation method. So, there are two types to solve any numerical problem. Either we put the value directly in a formula of a derivative, or we find once a function, then find the derivative, then we put the values. So, this one is all about numerical differentiation.